In this section, we're going to talk about properties of continuity and apply them. Our objective is to use properties of continuity. So basically in these 5 properties, remember B is a real number, F and G are continuous. F and G are continuous functions, that's a given. At x equals c, the following functions must also be continuous at x equals c. Multiply by a scalar to the function, it still will be a continuous function. Add or subtract continuous functions, multiply, divide, compose continuous functions. Remember f of g of x, etc. Now, the only issue we have is when we're dividing, we know the denominator can't equal 0, so watch out for that. Basically, just remember that any combination of continuous functions makes a continuous function. Okay? Look at one example. Now this is from an AP exam. Which of the following functions are continuous for all real numbers x? Now I look at the first one, and this would be, I would let you know if this is calculator. This one is non-calculator, so we can't plug this in our calculator. Look at a graph and just see that it can be drawn without picking up your pencil. And I don't know what this looks like, but I know what each of the pieces looks like. Y equals e to the x. I know that that's an exponential function. That is a continuous function. Y equals x squared. I know that that's a continuous function. Y equals sine of x. I know that that's a continuous function. Therefore, if this is made up of continuous functions, this function has to be continuous as well. So which of the following functions are continuous? Are continuous. Be careful, sometimes it says is not. This one is continuous. But on these exams, we find one answer. We don't necessarily stop there. Sometimes it's more than one answer. Let's look at the next one. Again, I don't know what it looks like, but I do know what the parts look like. Remember multiplying. We can multiply continuous functions and still get a continuous function. So I'm thinking of y equals 3x is going to just be linear. I'm thinking of just this guy in here. Y equals x squared plus 7 is going again to be a parabola. Then I'm thinking of this outer function right here, this square root function, and y equals the square root of x looks like that, also a continuous function. Now this quadratic and this square root function are composed into each other. These are compositions. The quadratic is inside the square root function. And remember, composition also leads to continuous functions. So I'm multiplying a continuous times a composition of continuous. Therefore, this is also continuous. This one, secant x. I don't know if you remember what the graph looks like, but I hope you remember at least that secant x is the same as 1 over cosine of x. Well, guess what? Now we have a denominator, and the denominator cannot equal 0. Does cosine of x equal 0? Yes, it does. It equals 0 at a variety of places. At 0, sorry, not at 0, at pi over 2, at 3 pi over 2. Keep going. There's a lot of places where it equals 0. We can't have a denominator equaling 0, so this one is not going to be continuous. Here's another excellent example from an AP test. This is a combination of continuous functions, but in a different way, in piecewise style. So here I see we've got a linear function, a quartic function, a quadratic function. All polynomials are going to be continuous. Let's see what it's asking. Let h be defined by the following. For what values of x is h not continuous? So we might say, well, this is a combination of continuous functions, therefore it has to be continuous everywhere. That is not true. Look at the constraints. Where does it break apart? First place where we see is this piece ends at -2, this piece begins at -2. Now I see that equal sign, so maybe they come together. Let's check it out. So I'm going to take these two right here, and I'm going to check out their limits to see if they come together. So the limit as x approaches -2 from the left. So from the left would be this part where x is less than -2. So that's going to be using 3x minus 7. I use direct substitution, plug in -2, and I get -13. Let's check it out from the right when x is greater than -2. So I do the limit as x approaches -2 from the right. That's going to be for negative x to the 4th plus 3. Again, use direct substitution, the negative of negative 2 to the fourth plus 3 again makes negative 13. So look at that. From the left and from the right, I get the same limit. Therefore, the limit as x approaches negative 2 for this function h of x exists. It has a value. I need also to check, is there a function value, h of negative 2. Well, h of negative 2, I see that there's an equals right there, which I mentioned earlier, so I use this one because it's equal. That will be 3 times negative 2 minus 7. That will be negative 13. So here I see my 3 parts of the definition of continuity. 1, the function is defined at negative 2. I got a value. 2, the limit exists. I got a value. I probably should have done this one first. 2, I got a value. And 3, those are the same as each other. The limit as x approaches negative 2 equals h of negative 2. So far so good, it's continuous. Let's look at another place where they could possibly break apart. Here is where x is less than negative 2. Here is where x is positive 2, greater than positive 2. And you know what? I'm going to do it in the correct order this time because doing the limit first is a lot of work. If I don't want to do a lot of work, I might not need to even do that part. So let's check out the first part of the definition. So first part of the definition says that h of 2 must exist. So let's look. What is h of 2? Uh-oh, I don't see an equals. I can't find h of 2, so it doesn't equal anything. H of 2 does not exist. Therefore, h is not continuous at x equals 2. For what values of x is h not continuous? And there we answered it. Here's a similar question written slightly differently. For what value of the constant c is the function of f continuous over all the real numbers? So remember, to be continuous, those 3 things that have to occur: the function value exists. Sorry, I don't want to write f of x. I want to write the function value at some x value exists. The limit as x approaches that value of the function exists. And thirdly, we put them together. The limit equals that function value. So where might that function value be? Now I see a linear, I see a quadratic, they are both continuous. Therefore, the place where they might not be continuous is in the constraints, where they might be broken apart. So first thing I'm going to look at, does f of 3 exist? So if I plug 3 in to here, I get c times 3 plus 1. That's 3c plus 1. Well, I can't go any further. In fact, they're actually asking me what value of c is this going to happen. So let's go ahead to the second part of the definition. Second part says I need a limit. So the limit as x approaches 3 for this function has to exist. Now remember, that means from the left and from the right. So let's do the limit as x approaches 3 from the left. So from the left, less than 3 is cx plus 1, and that has to equal the limit as x approaches 3 from the right. From the right, bigger than 3, that's going to be this guy, cx squared minus 1. Now they have to equal each other, so let's go ahead and do the left side using direct substitution. Plug in 3, c times 3 plus 1 has to equal c times 3 squared minus 1. This is 3c plus 1 has to equal 9c minus 1. Go ahead and solve this equation to get c equals 1/3. So when c equals 1/3, that's going to make our function continuous.